right, awesome. Well, thanks everybody for joining us. Appreciate you guys spending some time with us. I know this is the last session of the day, and Alex and I are the only ones that stand between you and happy hour or your events tonight. So we promise to make it as interesting as we can. Um, so today we're going to be talking about how to design firewall deployments to protect your internet-facing workloads. And we'll do some introductions here. My name is Nick Koval. I've been with AWS about a year and a half now, a little bit over a year and a half. And I work in our networking go-to-market team. And I am responsible for our network security go-to-market strategy for our network security services and solutions. And that includes many of the services that we're covering today. So a little bit about me. Before joining AWS, I worked in the managed network services sector in the industry for about 20 years. I had a variety of different roles from network engineer, network architect, product development, product marketing, business development. I kind of wore all the hats. So I have a lot of experience in networking and security before I even came to AWS. And currently I live in Pittsburgh, Pennsylvania with my wife and 2 daughters. And when I'm not working, we like to travel, play sports, and I'm a technologist at heart. So I like to automate everything at home. And that sometimes irritates my wife and the kids because oftentimes I can't figure out how to turn the lights on or do things like that. Or, why is the washer going off? We'll figure that out later. But that's kind of what I like to tinker with at home. And want to introduce Alex. Alex, you want to introduce yourself?
Awesome. Yeah, my name is Alex. I'm a senior networking specialist solutions architect with AWS. I know it's a mouthful of a title. It's not what I do, that's my title. So yeah, I'm working in strategic accounts. My role is to help AWS customers design their networks, implement the best practices, and sort of find solutions to their challenges and the problems and the deployments that they want to create on AWS. Been in networking for all my life, or all my active life in the field of working people, for almost 10 years now. Been with AWS for a bit over a year and a half as well, like Nick here. I used to work with AWS deploying data centers in Dublin, so I kind of know that the cloud is not the cloud, it's just someone else's computer. So that gives me a bit of perspective on why some of the considerations are important when we're designing networks in the cloud. Pretty passionate about security. That's why I'm here today. And the inbound inspection architectures, hopefully they're going to be a very relatable type of challenge that you folks have. And hopefully we're going to be able to give you some answers today to those questions and to the needs that you have to deploy infrastructure on AWS. So, Nick, do you
Awesome.
want to take us
Yeah,
through
I'll take
the
it from there.
first part?
Great, thanks, Alex. All right, let's dive in a little bit. So just a little bit of context, we're going to go through 200 level and 300 level content today. So I'll start with the 200 level, and I'll cover some of the strategy and frameworks that will help you make decisions to select your firewall solutions or technologies. And then Alex will dive deep into the foundational constructs and all of the reference architectures, the details that you need to actually get things done, put things in place. So we'll just walk a little bit through the agenda. I'm going to start by covering the NIST cybersecurity framework, helps you contextualize and manage the cybersecurity risk in your environment. Then I'll go through our network protection use cases. Will help us understand how and where to put firewalls in your environment to protect your assets in different ways. Then I'll go through security defense in depth from the network edge. The defense in depth strategy to get a sense for what services fit where in the different stacks to help you identify threats and mitigate risk. And then I'll hand it over to Alex. She'll dive into some of the foundational constructs to help you understand that you need to understand before you get to the point of designing and implementing the solutions. And then finally, she'll deep dive into the reference architectures and the inspection architectures to help to provide prescriptive guidance on how to put these solutions in place in your environment today. All right, so the NIST cybersecurity framework is voluntary guidance that NIST has put together that consists of standards and practices that allow you to reduce, to manage and reduce your cybersecurity risk. And not only does it help you reduce risk, but it also provides a framework for some productive conversations that you can have between your internal stakeholders and external stakeholders. There's often this collaboration is required in order to fundamentally manage your risk and implement best practices. The other thing to note is that it is designed for for businesses of all sizes. So whether you're an emerging startup that's ramping, that's brand new, or you're a large global enterprise, this framework and the guidance in here will be able to help you within your environment today. All right, so it has 5 different stages, and I'll go through each one of them here. First is identify, and this is the stage where identify the assets and the processes within your environment that need protection. Then the next stage is the actual protection. These are the tools and the services that you'll implement and put in place and service in your environment to actually protect the traffic or secure traffic and protect your assets that you've identified in the initial stage. Then you have your detection stage. This is where you have techniques to identify incidents that occur if they do within your environment. And then and the next stage is where you manage your response. These are the techniques that allow you to limit the impact that incidents have within your environment. And then lastly is your recovery phase, where you identify the capabilities you have to restore services to where they were before the incident happened, for example. Now let's take a look and overlay our AWS security and network services into the framework here to see how they map into your environment. So in the identity phase, services like AWS config and systems manager help you identify specific assets within your environment and different parts of the environment that you want to identify as needing protection. And then in the protect stage, you have all the services that we're going to spend time talking about today. This is where your firewall services come in, your networking services, VPC, services like firewall manage that help you manage all of your different firewall services within your AWS environment. Then you have services in the detect phase, such as Guard Duty and Security Hub. And these particular services will help you identify incidents that occur within your environment. And then as you go through the cycle of getting into your response, you can use services like AWS Lambda to automate some of your response once incidents happen, and you can trigger events based on that. And you can do your investigation with services like CloudTrail, so you can look into the history of the events that occurred in your environment and figure out how to take action with those automated steps. And then lastly, in the recover phase is where you can use services like AWS CloudFormation to help you deploy or redeploy infrastructure to replace pieces that were compromised or damaged as a result of an incident, and then restore well-known or good resources to a known good state in your environment, such as snapshots on EC2 images, for example. And then just to kind of emphasize, today we're going to dive into this protect phase and talk more about these for the remainder of the session today. All right, so there's a couple of network protection use cases that generalize how you think about securing traffic in and out of and around your AWS environment. And so the first one here is internet ingress. This is when traffic is coming from the outside in. So think about it as untrusted traffic coming from the internet, coming across the boundary, the edge of AWS into your trusted environment. And then there's outbound or egress use case. This is where you're filtering or securing traffic that's leaving your environment, going from your trusted inside to the untrusted outside. And then lastly, you have lateral or east-west, and this is securing traffic that's moving within your AWS environment. This could be from workload to workload, or could be from users to workload, or between users and workloads. And this also encompasses use cases for protecting traffic to and from on-prem, whether it's going through a VPN connection, VPN service, or maybe Direct Connect, for example. So it's also important to note that we recommend you deploy these different protection use cases independently. And so the reason is to for the greatest amount of control and minimizing the blast radius, it's important to be able to have the ability to deploy them independently so that there's different resources that are responsible for doing these different types of protection. Now, some customers we do have seen combine them together, and that's mainly to address budgetary concerns, or sometimes there's compliance reasons that the different um, use cases have to be deployed together. But the most common way is to deploy them independently, and that's what we recommend customers do. And we're going to today just kind of set the stage. We're going to dive into the Ingress use case throughout today. But keep in mind, we're going to talk about how to secure that traffic coming into your environment, but it often doesn't end there. If you have a 3-tier web application, once the traffic comes in through the network edge and lands on a private subnet on your workload, it may be that traffic may be initiating additional traffic, and so there's other effects you have to keep in mind as traffic. Then as that triggers other traffic to move laterally within your environment. All right, so I'm going to talk a little bit about defense in depth from the network edge. And so this is how you apply the many networking and security services that AWS has, put them in a service chain so that you can effectively secure your traffic as it goes from the untrusted internet to your trusted workload. And so some of the foundational constructs are kind of like the containers for these services and workloads that you're going to put in place. So these are your VPCs and your subnets. These kind of create the boundaries within your AWS environment that you define your security policies around. And then let's walk kind of through the life of a packet as it goes from on the left side of the screen from the internet all the way to the right-hand side to your workload. So the first service that we have that helps you in this is called AWS Shield. And this is a service that helps mitigate denial of service and distributed denial of service attacks. And the beauty about Shield is that it's actually enabled by default, and it doesn't require any additional configuration on your behalf. It does offer a Shield Advanced capability, which allows you to coordinate with our response teams if you want to get additional help by being able to respond to a denial of service attack and actually inject some changes into your environment as a result of what happened to try to help mitigate it and mitigate that incident from happening further. All right, so as you get a little bit further into your environment, now you're at the point where you're going to select some firewall options. And these are dependent on the type of application workload that you're protecting. And so these roughly fall into like 2 categories. You have your web applications and then your non-web apps. And we recommend customers deploy the firewall solution based on that type of workload and not them together. So for example, if you have a web app, you deploy your WAF, but you won't need your network firewall. Unless you have multiple different types of workloads traversing the same environment, then you actually may use both of those types of firewalls within your environment. And once the traffic goes through your firewalls, then the next phase is to put it through a load balancer, which will then distribute the traffic in a highly available way across your workloads. And this is very similar to the firewalls. We have load balancers such as the application load balancer that's designed for web apps. And we have a network load balancer, or NLB, that's designed for non-web apps. And this is an example of how you use these different load balancers to map to the specific use case that you have, your workload type. So use WAF with ALB, and WAF is actually integrated with ALB, or you use your network firewall, you can with NLB, for example. And then the last kind of security service and capability that you have in your repertoire here is to refine controls and access controls between some of these boundaries. So for example, security groups is a very easy way, that offers fine-grained control to restrict access between resources within your AWS environment. And what this allows you to do is, and security groups can reference other security groups. So for example, you can attach a security group to your workloads, and you can attach a different security group to your load balancers. and you can program or configure the security group of the workload to only allow traffic that comes from the security group with the load balancer in, and the specific type of load balancer you have in this case that we're showing here, like the ALB. And then at the subnet level, you can deploy or configure network access lists, or NACLs. And those are a broader way to control access that works on like the 5-tuple level, where commonly one way to use these is to, for example, add a NACL that will control or only allow port 80 or 443 traffic if you're building a web application. So that can prevent other additional misconfigurations in your environment, or other teams, for example, from putting an NLB in place, because that traffic wouldn't be able to traverse the boundary between your private subnet or your public subnet and your private subnet if you had that defined. So it's just another layer of security to add there. And then lastly, we have a set of other services that help you either more finely control access within your environment. There are services like VPC flow logs and traffic mirroring that allow you to get visibility into the types of traffic flows that are traversing your environment across the different boundaries. And traffic mirroring allows you to actually copy it's basically like a distributed sniffer. It allows you to take the payload, the full packet as it's traversing, and then copy it over to another location in your environment to send it to a sensor, for example, that might do some threat analysis. There's also guard duty that allows you to inspect or identify events as they occur within your environment. There's DNS firewall, or Route 53 DNS firewall, that allows you to prevent and restrict traffic before it even gets into your environment. So the best way to address your security threats is to block them before they even reach the edge. Now let's just zoom out a little bit and think about how to choose the right tool for the job. We talked about a bunch of different tools here, and there's a couple of ways that we can think about selecting which tool works best for your particular environment. And so the first lens we'll look through is doing a risk assessment and understanding compliances that you have. The risk assessment process allows you to specifically identify what assets you want to protect, what type of vulnerabilities you need to protect them from, and that will allow you to refine what type of tools you need to apply. And then also take into consideration the compliances that you have to comply with. And this could be internal compliance, external compliance, regulatory compliance. There's a lot of these compliance frameworks that we have to operate within, and they sometimes also provide guidance on specific types of tools or capabilities that we have to add from a protection perspective. And then second is the budget. You always want to take into consideration the ways to minimize your spend by selecting the tools or the minimum set of tools and features you need to protect your environment. This will help keep finance happy by minimizing how much money you spend. And it's important to know that when you look at the firewall services that are available, AWS has native services, and we also have partner solutions that offer similar and different features. And so depending on the service and the type of firewall, for example, you need, and the offering that you want to use, whether it's a native service or a partner service, that'll come with different cost structures. And sometimes the individual service will actually have different costs associated to different features. So that allows you to more granular way of controlling your costs by only enabling the features that you need, for example. And then the last way to look at this, and this is an area that Alex is going to really dive deep into, is your deployment models. There's two broad deployment models that we see customers deploying, and that a lot of our reference architectures are built around. And the one is a distributed model, which is, let's just say you have hundreds of VPCs. The distributed model approach is when you deploy your network security protections within you push it out to the edge of all of those VPCs, for example. And this could be deploying a firewall within each VPC. And sometimes customers are using this particular model to enable fine level control of the security services at different levels within the organization. So if a VPC maps to a business unit, then that gives them the full autonomy and control to implement policies within their environment, and also minimizes or prevents them from having the ability to affect other business units that have VPCs that are using similar services but not sharing the same state or policy or configuration. And then, but the most common deployment model that we see customers using with our firewall deployments is the centralized model. And one of the, there's two main advantages to that. It's centralized control, meaning you have less things to configure. And if you have a central IT organization, that's often easier for them. And it also provides you greater cost control, because when you centralize all of your services into a single VPC, single inspection VPC, for example, you have to deploy less infrastructure, and that keeps your costs down. All right, so with that, I'm going to hand it over to Alex, and I'm going to let her dive deep into our networking, some of our foundational constructs.
Thank you.
Sure.
Thank you. That's awesome. So let's look at the actual architectures. And before we do that, the first thing that we need to level set and to baseline on are some of the foundational constructs that we're going to use in the architectures to make sure we deploy those inspection points the way in which we've decided to. And the first one is Amazon VPC fundamentals. Let's level set here. And the Amazon VPC, as its name stands, is a virtual network where you can deploy your infrastructure, workloads, like EC2 instances, for example. The Amazon VPC is a regional construct, right? So it's defined by the IPv4 and IPv6 addresses that you add at creation time or afterwards you attach to the VPC. And you folks know that each region is composed of multiple availability zones. So in order to leverage the high availability given by multi-AZ deployments, you do have to deploy subnets in each of the availability zones that you want to use. Now, the important thing is in AWS, you have two types of subnets, public subnets and private subnets. You don't create them as being public or private. Subnets are subnets. What defines them as public or private, or what gives them this feature or capability, is their routing, right? So we're going to dive a bit deeper into routing in a second. Now, in our subnets, I mentioned that we can deploy our workloads, either EC2 instances. I've put there a NAT gateway because it's a favorite at this point in terms of IPv4 NATing. And once we've done this, we have our environment in the VPC. Outside of the VPC, there are services in the AWS cloud that are managed services and are not deployable in the VPC. Those are just some examples. You can also privately access these services using AWS Private Link. So you have different connectivity options for your workloads and those services. One thing that we do need to focus on, because we're talking about inspection architectures today and inbound inspection architectures, is the internet, right? And internet connectivity. This is ensured by the internet gateway for IPv4 and IPv6 in terms of public subnets. And the egress-only internet gateway, which is ensuring the private feature of a subnet in IPv6, whilst the NAT gateway is helping us provide internet connectivity to our private subnets on IPv4. So these constructs here being level set and established, we can move a bit further, and we can look at routing, because routing is that piece of the configuration and the networking side of the house that is going to ensure the security implementation, right? And the fact that that traffic is going to be inspected at the point where we want it to be inspected. So the first one is subnet routing. You are all probably very familiar with it. It's the classical default routing that happens in a VPC for a subnet. Every route table in our VPC, route table to which subnets are associated, has the default CIDR association in it. You cannot remove those CIDRs that are associated with the VPC, and traffic within the VPC flows according to that local route, or local routes if you have multiple CIDRs associated with the VPC. Now, in terms of types of routing, the subnet routing, the classical one, I've mentioned that the private subnets and public subnets, their capacity of private or public is given by routing. So for a private subnet, the default route is towards an AD gateway in IPv4 or towards an egress-only internet gateway in IPv6, while for the public subnet, the default route goes to the internet gateway, right? So traffic is routed symmetrically between the subnets and the internet gateway and the internet. Now, we do have the second type of routing here, which is the ingress routing, which allows us to direct traffic in a non-default way, right? So by default, in our VPC, the internet gateway is the one that does the one-to-one NAT or network address translation between the private IP address of a workload and its elastic IP, right? We can have a public EC2 instance or the NAT gateway. They all have elastic IPs associated, right? Internet gateway does that one-to-one NAT, and it's the one that sends traffic to the actual public-facing workload. Now, the default routing behavior of the internet gateway is also to match the local route, right? But if we want to alter that, we can do that by associating an ingress route table to the internet gateway and specifying the fact that the traffic is no longer flowing in a default way to the public subnet, but it is going to be inspected by an endpoint, right? So we can direct traffic through an ENI in our VPC in a different subnet. The more routes there in the ingress route table have to match a subnet CIDR, right? So they have to be matched exactly. Now, the public subnet route table, in our case, it's the subnet where we have the endpoint. It has the local route, so it routes locally, and then sends that traffic to the instance. Now, from the private subnet perspective, the default route has to direct traffic to flow through the endpoint because of that symmetry need, right? So traffic will flow back in a symmetrical fashion. Now, our third type of routing, which will also play a very important role in our security deployment, is more specific routing. What happens here is the fact that we can direct traffic between two subnets in our same VPC, right, through that inspection endpoint. So when we want to insert the either appliances or firewall functions in the path of the traffic, we wouldn't be able to do that using just the local route, right? So we do need this more specific routing type of configuration, right? So the more specific route directs traffic to the endpoint or appliance, and the endpoint subnet routes traffic according to the local route. And for symmetry, we do need to configure the routing behavior to flow back through the endpoints and to the originating subnet. So these three routing configurations are the ones that are going to help us with our inspection architectures. Now, ingress routing versus more specific routing. What is the difference between them, and why should we care in terms of security? Well, when we're inserting that firewall function, right, in the path of the traffic, we do need to understand what the difference is if we first inspect the traffic and then that traffic hits our workload, or if the traffic hits the workload first and then we inspect it, right? So different inspection points yields in different results for that traffic, right? First and foremost, the firewall will see inbound traffic with ingress routing, right? So the firewall is the first point that is intaking that traffic and makes the decision of passing the traffic or rejecting it. In our second deployment with more specific routing, the firewall sees traffic that is already accepted by the load balancer, right? So if you have, for example, on your load balancer, a HTTPS listener, right? That traffic is intaken. You can filter on the load balancer, for example, who your clients can be. And once that traffic is intaken by the load balancer, the firewall function comes into play and filters that traffic between the load balancer and the targets. So it is very important to understand why we're doing the separation. The client IP is also seen or not seen by the firewall, right? So if you want to implement rules at the firewall level, matching the client IP, you do need to understand if you can see it, or if you need to pass that client IP in an additional header inserted by the load balancer, right? And third, in the firewall deployment being the first line in the traffic path, the firewall needs to be able to do the decryption. So it needs to have the certificates or whatever you're using to encrypt that traffic. It needs to be configured, and we're going to see in a second how we do that. In the deployment model with more specific routing, the traffic is inspected between the load balancer and the client. So if you want to have that traffic encrypted, again, you do need to have a private certificate on the firewall, or you are sending the traffic unencrypted between the load balancer and the client. So very important. Also a note, the more specific routing piece is not supported with network load balancers that are configured to preserve the client IP address with IP address target types or with instance types of targets. Why is that? Well, because when we have this configuration, the client IP address is the one that is going to flow and is going to be in the packet when that packet reaches the target, right? Not the address of the load balancer. So we've seen that more specific routing says, okay, we can route more specifically to subnets in our VPC through a third that it contains the inspection point. In this case, the client IP is not part of our VPC, right? So we've seen the fundamentals around VPC and VPC routing. Let's look at some pieces of the load balancing and how the different types of load balancers that we have play into this role. The first one is the difference between application load balancers and network load balancers. You folks know already at the functional level what they provide, but from the target types perspective, it's important to note these differences, right? The application load balancer is able to target natively an instance, an IP, or a Lambda function, but it's not able to target natively another application load balancer, right? So you cannot put these two together. The network load balancer, on the other hand, it is able to natively target an instance, an IP address, or an application load balancer. So it's natively integrated with the application load balancer like this. But it's not able to target natively a Lambda function. Why will this be important? Well, because in the architectures, we're going to see the different types of load balancers, where we use them and why, right? The second piece is the difference between an application or a network load balancer and the gateway load balancer. These two types of load balancers are the ones that enable us to integrate firewall appliances in the traffic path without changing the IP headers. Now, with the classical type of load balancer, the application or network load balancer, the traffic changes the header, right, at each point in the path. So the IP source, IP destination of the IP packet changes, right? With the gateway load balancer, in turn, because the gateway load balancer acts as a bump in the wire, so it's technically a very, very smart router, right? That keeps flow state and allows you to route symmetrical the inbound and outbound traffic from your firewall appliances. It does not change the IP source and IP destination of the packet. So it intakes that traffic and sends it in a highly available fashion to the firewall appliances that you have integrated with it. The third thing about load balancing is, because we've talked about inspection and the decryption of the traffic, right, is the integration with the certificate management option that you have. In AWS, you have the AWS Certificate Manager. You can generate public certificates there and manage them. And these public certificates are natively supported and integrated on Application Load Balancer and CloudFront. Now, if you have your certificates in a public certificate authority that is not AWS, you can import them into ACM, and they can again be used by these two services. Now, if you're choosing a firewall appliance or partner to integrate with Gateway Load Balancer and input that into your design deployment, you have to make sure that this firewall has the certificates that are managed outside of AWS, right? So it doesn't, they don't natively integrate with ACM. This being said, we've looked at foundational constructs. Let's look at design consideration. Why is design considerations important? Well, because first and foremost, we need to understand what are our options and what do we want to do in order to make a decision. So to help you, we've created a checklist. We call it the inbound inspection checklist because it takes us through those components and those decision points that we need to make in order to deploy our firewall design. Our checklist touches the most significant pieces of a design, which are related to what application types we want to inspect, right? Do we have HTTP, HTTPS applications? Do we have non-HTTP, HTTPS applications? What is exactly what we're trying to do at the application, right? The second piece is control plane and data plane. This is very important when we're talking about centralizing and decentralizing, right? We do want to understand what exactly are we centralizing? Do we want to centralize the control plane, or do we want to centralize the data plane, or do we want to do both, right? So we do need to understand what we need to do derived from the policies and enforcement mechanisms that we need to implement, and then we can make a decision. The third one is the inspection depth. Why is the inspection depth important? Because the capabilities of the services that you are using are different, right? So we need to choose the service based on what it can do. And the fourth one is scale. Do we need to inspect traffic in one VPC, in multiple VPCs? Do we have the entire internal network that we need to focus on, and so on? This checklist being here, we do have to answer the question, well, do we centralize or do we distribute? And I think this is an important one because we do need to first understand what are we centralizing and what are we distributing. The distributed ingress, in our case, is having the internet gateway at the level of each VPC, right? So this means that each VPC is able to have elastic IP addresses associated with resources. So it means that internet traffic from users flows directly into each of the VPCs. Now with centralized ingress, the VPCs do not have their own internet gateways, or they're not using them. And the traffic is flowing through a central edge VPC. Why is this important? Well, first thing, the VPCs that are being served by the edge VPC don't have an internet gateway on our diagram, right? So this is one consideration and one of the reasons why security folks are saying, okay, we want the centralized approach because we can control who can put the internet gateway on each VPC, right? But to keep in mind, there's not one size fits all. So from that perspective, you may have VPCs that don't have to have an internet gateway. You may also have VPCs that do. We're going to look at some considerations in the design area. So should I centralize or should I distribute the internet ingress? Well, there's pros and cons. Nick mentioned already the cost piece. We're going to see, though, that with the centralized piece, you do get data transfer costs added. So you do need to know these considerations. You do need to know the pros and cons. And based on what you need to implement and the policy for security that you need to enforce, you make the choice. Now, what is the toolbox of AWS services? Nick already mentioned some, but we're going to focus our approach a bit. We are going to look at AWS WAF and AWS Network Firewall. And both of them can be managed through AWS Firewall Manager for that centralized management piece, right? And we're going to look at Gateway Load Balancer and its integration with third-party firewall appliances and how we can deploy it. Now, architectures. One thing that I want to mention, if you folks have any questions or any thoughts, we're waiting for you next to the stage when the session finishes. So keep your questions warm. We're going to answer all of them. So for inbound inspection, our first service is AWS WAF, right? AWS Web Application Firewall. It is highly configurable, it's highly scalable, and the beauty of it is that you can integrate it natively with CloudFront and application load balancers, API gateway, and AppSync. Now, if you folks want to know more about the capabilities of each service, I do highly recommend you scan the QR codes and you go through the documentation. We're not going to focus on the capability of the service, but more on how it relates to the deployed architecture, right? So if we centralize, if we distribute, how do we do it? Now, let's look at our checklist, because this is going to be our guiding point throughout the architectures, right? What type of application does the WAF support? Well, HTTP, HTTPS applications. Control plane and data plane can be centralized, can be distributed. Inspection depth is application aware, because we do need to it is a web application firewall, so we do need to inspect web apps. And the scale can be one VPC or multiple VPCs. Now, let's look at data plane and the distributed architectures for the data plane. The first one is using application load balancers, because the ELB natively integrates with WAF. And we have our classical AWS application load balancer deployment in a VPC. We have the load balancer subnets, we have the target subnets, the target group, and we want to integrate the ELB with the WAF. ELB does need to perform TLS decryption, right? So it does need to decrypt the traffic. It does need to have the public certificate. And that's how the WAF is also going to do the inspection, right? Traffic comes in from the users, hits the AWS Web Application Firewall, integrated with the ELB, and the ELB sends the traffic to the targets. Now, CloudFront is also directly integratable with Web Application Firewall. So we can take our deployment and we can front it with CloudFront distribution, and traffic is going to, again, be inspected by the WAF, right? Now, our checklist. Data plane, distributed. Control plane, centralized with AWS Firewall Manager. So you can manage the WAF deployments and rules and lists in AWS Firewall Manager. Application type, HTTP, HTTPS, also non-HTTP, HTTPS, not for WAF directly, but with what you have behind, right? The load balancer. So you can integrate that with your additional inspection pieces. And the inspection depth is application level, right? So the WAF looks at the application, and you're able to configure the rules based on the application. Scale, one VPC or many VPCs, right? In our deployment here, we have a distributed data plane. So each VPC, each ELB is integrated with WAF. And you can also have that in a centralized fashion, not a centralized fashion, but for more VPCs, right? Now, the data plane can also be centralized, right? Let's look at how the architectures look like. We have the same integration, right, with ELB or CloudFront, but for the centralized piece, we do have to have connectivity between our edge VPC, where the application load balancer sits, and our target VPCs, where the actual workloads live, right? So we do want to centralize that internet ingress. A very important consideration here. The ELB is integrated with WAF. The traffic comes in, is inspected, and then needs to be directed to needs to be directed to the workloads. The important consideration here is that the management aspect of the centralized ingress, in this case, needs to be at that edge VPC layer, right? So the team who manages that needs to make sure that it responds to the needs of the teams who are actually exposing applications through that centralized edge VPC. Now, the data plane can be achieved with or can be configured using Transit Gateway, but it can also be configured using Private Link. So we have our same edge VPC, and we have VPC endpoints that are actually connecting or providing that transport layer connectivity between the edge VPC and the workload VPCs. The private link service integrates natively with Network Load Balancer, so it's built on top of Network Load Balancer. So if in the application VPCs you have application load balancers, here's where the integration between the NLB and the ALB is important, right? So you can front end the ALB with an NLB and integrate it with private link. Now, the ALB here in our edge VPC is integrated with WAF, and traffic comes in from the internet, is inspected, and then it's directed by the application load balancer to the correct endpoint in the backend. Considerations for our checklist: Ingress data plane is centralized. The control plane is again centralized using AWS Firewall Manager. Application type can be HTTP or non-HTTP, depending on your further integrations in the backend. Inspection depth is application level, and the scale can be one VPC or more VPCs, right? So we can have that horizontal layer of application VPCs that own the application. Our second service is Gateway Load Balancer. The Gateway Load Balancer, we've talked about it. It integrates natively, and it allows you to bring those third-party or open source appliances to AWS and to deploy them in a highly available fashion. Now, let's dive deep into the architectures. But first, our partners. This is the updated list as of today, not a comprehensive list, so they're not all of those. If you want to find out what other partners we have integrated with Gateway Load Balancer, please do check the AWS Partner Portal. And our checklist, again, we do need to focus on it. The Gateway Load Balancer, because it integrates with third-party appliances, it allows you to inspect the application type that those third-party appliances allow you to inspect. So based on their capabilities, right? You can deploy them in a centralized or in a distributed fashion, and the inspection depth is dependent on what the firewall capabilities are. Scale is, again, one VPC or multiple VPCs. Let's look at the distributed data plane. We have two options, with ingress routing and with more specific routing. With ingress routing, our deployment, again, stays the same: application or network load balancer that exposes our application targets in the backend. The way in which we can direct traffic to the Gateway Load Balancer is by sending that traffic to the Gateway Load Balancer endpoints, right? So the Gateway Load Balancer can live either in the same VPC or in a separate VPC. We've chosen to put it in a separate VPC to simplify the architecture. And the Gateway Load Balancer endpoints are the ones that are intaking the traffic and sending that traffic to the Gateway Load Balancer. So traffic comes in from the internet, and at the internet gateway, we configure that ingress route table, right? Specifying that the traffic for the public subnets needs to go through the Gateway Load Balancer endpoints. So traffic is directed to the endpoint. The endpoint sends the traffic to the firewall appliances behind the Gateway Load Balancer. Traffic is inspected, right? The firewall appliances need to perform decryption if the traffic is encrypted, and it's sent back to the same Gateway Load Balancer endpoint. The flow stickiness is also ensured by the Gateway Load Balancer, so you are going to have that traffic that's part of a single flow, right, sent to the same firewall appliance. Now, once the traffic is back, the normal VPC routing, subnet routing kicks in, and the route table says, okay, well, the local CIDR of the VPC instructs the gateway load balancer endpoint to send that traffic to the elastic load balancer. And the elastic load balancer sends back the traffic to the targets. Now, for the return path, we do have to have symmetry. So how are we going to have that? By configuring the routes in the route table to return the traffic to the same endpoint. With more specific routing, the difference is that the firewall, the gateway load balancer endpoint, the inspection using the firewall, is between the load balancer and the targets. So traffic comes in from the internet, again, hits the load balancer using the normal VPC routing, is sent by the load balancer to the gateway load balancer endpoint, right? And is inspected and then sent back to the targets. The return traffic needs to be symmetric. So we have the same routes in the target route tables that direct the traffic to the gateway load balancer endpoints. And traffic goes back to our users. Considerations here: the Ingress data plane is distributed. The control plane is centralized with the vendor tools of choice, right? Depending on which vendor you're using, they're going to have their tool. The application type is any type of application, HTTP, HTTPS, depending on the firewall capabilities. Inspection depth is application level, or again, whatever firewall capabilities the appliances have. And the scale is one or many VPCs. So the gateway load balancer endpoints that target or that belong to the same gateway load balancer can be deployed in multiple VPCs, right? What happens if we centralize the data plane? Well, again, we have two options with Transit Gateway and Ingress routing. So our same deployment as before stands in terms of the transport using Transit Gateway, and the gateway load balancer endpoints are the first line in the traffic flow. So the traffic comes into the VPC, it goes to the gateway load balancer endpoints, is inspected, and goes to the targets. With private link and Ingress routing, again, the gateway load balancer endpoints are before the load balancing options. So traffic is first inspected and then sent to the internal network. The same considerations for the Ingress data plane, we have it centralized. For the control plane, we can use the vendor tools. The application type can be any, and we do have the scale of one or many VPCs. For the data plane, we can also have Transit Gateway and more specific routing, and private link and more specific routing. The difference, or the only difference, being the fact that the traffic is inspected after it's approved or ingested by the load balancer. So traffic comes into the load balancer, it is directed to the gateway load balancer endpoints, and then to the internal network. Same happens with private link and more specific routing. Traffic comes in, is allowed in the VPC by in the application load balancer or the network one, and then directed to the inspection option. Same considerations apply. The Ingress data plane is centralized. The control plane is using firewall tools, vendor tools. The application inspection depth and scale are there to support our design. Now, one important call out here is the cloud next generation firewall solution that we've worked together with Palo Alto in partnership to natively deploy on AWS and integrate with AWS Firewall Manager. So it's the first next generation firewall that integrates with a Firewall Manager. If you folks want to know more about it, please do scan the QR code. And what this solution allows you to do is, you folks remember this diagram and this architecture. instead of you managing the VPC at the deployment level and the firewall instances, you do need to only focus on the routing because Palo Alto manages in the backend the deployment for you. So you don't need to worry about the actual management of infrastructure. Very important, you can, or you first will create the firewall rules in the Palo Alto Cloud Next Generation Firewall. And because it's natively integrated with Firewall Manager, in Firewall Manager, you choose which VPCs, which policies you need to apply. And those are going to be applied to your deployment, to your VPCs. You can manage the Cloud Next Generation Firewall by using either the Firewall Manager CLI or SDK, or your infrastructure as a code preferred option. Network Firewall. We've gotten to our third product. It is the native solution from AWS in terms of firewall and inspection and next generation firewalling functions. You don't need, again, to manage that infrastructure, right? So you are going to just deploy firewall endpoints in your VPCs. Our checklist, again, helps us define where the solution stands in. We can inspect any type of application, again, either TCP, UDP, or HTTP. The data plane is centralized or distributed. We're going to look at the deployments. We can do either port or IP filtering or application aware if the traffic is decrypted already, because the network firewall does not yet support decryption. And the scale is either one VPC or multiple VPCs. The deployment can be, again, data plane centralized or distributed. So looking at the distributed data plane, we have, again, two options with Ingress routing or more specific routing. And the only thing that changes is the fact that in our architecture before, we had the gateway load balancer. We had to manage the VPC with the firewall appliances. In this case, with the network firewall, you just deploy the firewall endpoints, and traffic is directed in the same way using the Ingress route table to the firewall endpoints. It is inspected using the rules that you configure in Firewall Manager, and then directed to the load balancer. Same routing constructs apply, right? So we do need to configure the Ingress routing and routing at the VPC level. The return traffic needs to be, again, symmetrical. So we do need to make sure that those route tables are configured appropriately. With more specific routing, again, the firewall function will stay between the load balancer and the targets, and the traffic will flow from the elastic load balancer to the firewall endpoints and then to the targets. Now, for traffic to be symmetrical, we do need to have those same routes in the route tables that direct the traffic to the appropriate endpoint. The same checklist applies and is here for us to direct the solution in terms of its capabilities. So the data plane is distributed, the control plane is with Firewall Manager. So you can manage the AWS Network Firewall policies centrally with the Firewall Manager. The application type is any, and it has to be decrypted. And the scale is one or many VPCs. If we choose to have the data plane centralized, we can employ the same architectures. Instead of gateway load balancer endpoints, what we had in the previous architecture, we have the network firewall endpoints, and the traffic is going to flow as expected through the firewall endpoints, inspected, and be sent to the load balancer. With private link and ingress routing, the same architecture stands. We have the firewall endpoints as a first line of traffic. The Ingress data plane is centralized. The control plane, again, centralized with Firewall Manager. Application type is any, as long as it's not encrypted. Inspection depth is application level. So with the network firewall, you can do port type, port IP type of inspection, or you can choose to do application layer using Suricata rules or manage rules. And the scale is one VPC or many VPCs. Now, for the data plane, we have, for the centralized data plane, you can also use transit gateway and more specific routing. So again, traffic goes first to the load balancer and then is inspected. And we can also use private link and more specific routing. So these architectures don't change much. The only important thing is for us to understand what we need to do in terms of inspection. I will keep you for one more minute while we go through the checklist and through the solution that will make you hungry probably, which is the Elastic Load Balancer sandwich. It's a popular solution. It's not as new as the ones that we've talked about, but it is still deployed by our customers, so it was worth talking about it. The data plane is distributed because of the way in which the deployment looks like. So the firewall sandwich is actually, the ELB sandwich is actually creating a sandwich in our architecture, so putting the firewall between two load balancers, which means that the traffic will flow in our expected way from load balancer to the firewall to another load balancer. Now, if we do need to look at the same checklist, we have the capabilities outlined for this. A call out is if we want to do this, we have to deploy firewall appliances in each VPC if we have multiple VPCs, because they're not integrated with gateway load balance. The centralized data plane is providing us with the same architecture using transit gateway or using the private link and more specific routing. So traffic flow is as expected. Now, if we put everything together, what do we need to do? We first need to, as Nick was mentioning, align ourselves with a policy, right, with a framework. Then we need to perform the risk assessment, and we do need to understand what is the functionality we're looking for. We need to consider the budget and the cost, and we need to get the checklist in place, right? That being said, thank you so much. Thank you for your patience, and thank you for being with us at 6 p.m. Please let us know if you have any questions. Nick and myself are here to answer them. Thank you so much.